This is a video of the do's and don'ts for trigonometry in C3. So first of all, some tips and things to look out for. The word hence, whenever you see the word hence, it means you're going to use your answer from before. Really important you remember that. Too often I see students starting part B or C of the question as if it was a completely brand new question. Just remember, you see that word hence, it means you're going to use your answer from before. So just remember that. Be on the lookout for seeing things like this, the product of the product of sine and cos. If that function on the inside there, if that's the same, then you can use the sine double angle formula. In this case here, this would be the same as half sine 10x, okay? Because obviously these are going to be doubled, but there's no 2 in the front, so that's why it's a half there. So just remember that be on the lookout for things where you sort of sine something, cos something, and that's something to say. If it's not the same, if I've got a 7x and a 5x there, then what you'll need to do is use the sine A plus B minus sine A minus B. In this case, A would be 7, B would be 5. Substituting those in there and there will allow you to rewrite that. Next tip, be on the lookout for double angles. So for example, if I'm asked to prove this, if I see that I've got a double angle here and a single angle there, and again double angle, single angle, you're going to need to get rid of the double angle. So you're going to need to expand those out. So always be on the lookout. If you see a 2x mixed up with an x somewhere else, make sure you expand the double angles so they match with the single angles. The only time you won't do something like that is if you have a 2x repeated with no other single angles there. So for example, if I'm given the equation sine 2x equals a half, that's actually an equation from AS rather than A2. But you wouldn't start expanding this here. You just change the range like you did in year 12. So that's the only time really you wouldn't expand that double angle. But if you have a double angle with a single angle, just make sure you expand those double angles. Next tip, just remember those sorts of equations where if you have something like tan squared x plus sec x equals 0, just remember that you're going to change this to be sec squared minus 1. You're always going to change the squared identity so it matches your identity, your trigonometric function in the middle there. So just remember, just like you did in AS where you had sine squared and cos squared, you're going to change the squared to match that. Another tip with regarding to proving things, proving trigonometric identities, if you have two fractions, so something like, I don't know, 1 over cos A minus 1 over sine 2A, I don't know, something like that. First thing I'd do is get rid of the double angle, based on what I said a couple of moments ago. Second thing I'd do is I'd want to get a common denominator, because I've got two separate fractions. You'll be amazed how much will simplify once you've got a common denominator. So if you have two fractions, make sure you get a common denominator so you can bring them together. Another tip with regards to proof, if you're really stuck and you can't get it any further and you've tried writing it all out using all the identities that you know and you can't seem to get the right answer, what I would suggest you do is you try and simplify things as much as possible and just write everything in terms of sine and cos. If that means you've got 1 over sine instead of cosec, and if it means you've got 1 over cos instead of sec, then at least you know by writing it all in terms of sine and cos, you might eventually get some simplification. Only do that if you get really stuck though and you've got an extra 10 minutes left at the end of the exam, and go back and try and just write everything in terms of sine and cos. Like I say, only do that if you're really stuck though. Next tip, if you're asked to solve cot 2x equals 0, now the way that we would usually solve that is we would say, well, cot is the same thing as 1 over tan. So if I've got cot 2x is 0, then I would say that 1 over tan 2x is equal to 0. So then I would end up having to say that tan 2x is 1 over 0. Which obviously your calculator is going to tell you that that is an error. It's undefined. But let's just remember, we have that's where the asymptotes come from on the tan graph. So this does have a solution. Your calculator is not going to tell it you, but it does have a solution. So think about where the asymptotes are on the tan graph. It's at pi over 2, 3 pi over 2, 5 pi over 2, and so on. So this does have solutions. Remember that. Last tip. Arc sine, I know some of you get really confused about that. You can just replace that. It means exactly the same thing as sine minus 1. So if you want to rewrite that like that, you can. So whether you're trying to solve an equation or sketch what it looks like as a graph or whatever it is, sometimes writing it like that will make it easier for you. Some common mistakes to avoid. An equation like tan squared x equals 2, quite often students write, well, tan x is going to equal root 2, but they forget the minus root 2 as well. So you need to have both, otherwise you will end up missing solutions. Okay, so make sure if you square root here, make sure you get the plus root 2 and the minus root 2, and you'll get solutions from both of those. Next tip, another really common mistake is students cancel signs without really thinking about it. Don't do that, you will lose solutions. Make sure you put everything onto one side, so 2 sine x minus sine x tan x equals 0, factorise the sign and then solve from there. So be really careful about that. Another common mistake is if you're asked to write so it's the question where you have something like 5 sine theta plus 4 cos theta, and you're asked to rewrite that in terms of r sine theta plus a. Make sure you actually expand this out, because too often students just jump and skip steps and then start writing down, oh, well, I think tan a is going to be such and such, without actually expanding this out, and then they go wrong. And then they lose 3 marks from this part of the question, and then they'll lose another 5 marks in part B of the question, all because they've just skipped doing this one step. So make sure you actually write this out as r sine theta cos a plus r cos theta sine a, then compare, so comparing r sine a with the 4, the r cos a with the 5, so now we can and go from there. Don't skip steps, really important. Next, that squared there is really important, especially when it comes to working out the minimum value of this. You know how usually when we work something out, the minimum value would be minus whatever that number at the front is. But that squared, that squares that minus, which actually means you end up getting a maximum, not the minimum. When you square this, the minimum it can be is 0. So just remember that. Be careful of those powers. And finally, if you have something like this, and this would be part B of the question, and in part A, you've probably rewritten that. So you'd have rewritten that in the form of r sine theta plus a. Part B would say hence, and then we make a substitution here. Far too often, I see students forgetting about that minus 1. They just go, right, 1 over r sine theta plus a, and just go from there, whether it's an equation or working out the maximum and minimum or whatever it is. They forget about the minus 1. So make sure that you include that. Be really careful with that. final thing to say about something like this, because it's the reciprocal, just remember that the maximum of this whole thing is going to take place when the denominator is a minimum. Because you want to divide by the smallest thing possible. And vice versa, the minimum of this whole function is going to take place when your denominator is a maximum, because you want to divide by a big number. So just bear that in mind as well.